Hello everyone, welcome to the Labkafe's practical session. In this session, we will do experiment on simple pendulum. The aim of the experiment is using a simple pendulum, plot LT square graph and use it to find the effective length of seconds pendulum. Materials required: a clamp with stand, a bob with hook, a split cork, a stop clock, a Vernier caliper, cotton thread and a half meter scale. Before we do the experiment, let's talk about a simple pendulum and its working principle. In addition to that, we will see how to operate a stop clock and take reading. A simple pendulum consists of a heavy metallic sphere, usually made of brass, with a hook suspended from a rigid stand with a clamp by a weightless, inextensible and perfectly flexible thread through a slit cork. The metallic sphere is called bob. It is capable of oscillating in a single plane without any friction with a small amplitude less than 15 degrees. A simple pendulum which completes one oscillation in 2 seconds is called seconds pendulum. There is no ideal simple pendulum in practice. The spherical bob may be considered as a point mass at its center G. The distance between point of suspension S and the center of G of the spherical bob is to be regarded as effective length of the pendulum. If the radius of bob is R, the length of hook is H and the length of thread is L, then the effective length of a simple pendulum is L equals to L plus H plus R. A simple pendulum produces simple harmonic motion as the acceleration of pendulum bob is directly proportional to its displacement from the mean position. The time period T of a simple pendulum for oscillations of small amplitude is given by the relation T equals to 2 pi root over L by G, where L is the effective length of the pendulum and G is the acceleration due to gravity. By squaring on both sides, we have T square equals to 4 pi square by G into L. Here 4 pi square by G is a constant. So, if we plot T square along y-axis and L along x-axis, we should get a straight line passing through the origin. This is a stop clock. A stop clock has one smaller hand and one longer hand. The smaller hand is used to start and stop the clock. And the longer hand is used to reset the clock. There are two dials in the stop clock. The bigger dial counts the seconds and the smaller dial counts the minutes. One complete rotation of the pointer in the bigger dial is 60 seconds. As you can see, there are 10 divisions from 0 to 5 seconds. Therefore, one division is 5 by 10 equals to 0.5 seconds. So, the least count of the stop clock is 0.5 seconds. Now that we know what is a simple pendulum and we also know the least count of the stop clock, let's do the experiment. Procedure. First, I will measure the mean diameter of bob by Vernier caliper. Here, I have taken 3 different readings and calculate the average as explained in the experiment number 1. I measure the length of hook by a meter scale. As you can see, the length of the hook is 1.1 cm. Now that the radius R and the length of hook H of the bob is known, I will adjust the length of the thread L to make effective length 35 cm. To do so, first I will tie the thread with the hook of the bob. Then, after calculation, I found the length of the thread is 32.9 cm. Now, I will measure it with a meter scale and mark the point on the thread with a pen. Similarly, mark 5 more points on the thread as distance 37.9, 42.9, 47.9, 52.9, 57.9 cm respectively. After that, pass the thread through the 2 half pieces of the split cork coming out just from the first ink mark. Tight the split cork between the clamp such that the line of separation of two pieces of the split cork is at a right angle to the line along which the pendulum oscillates. Fix the clamp in the stand and place it on the table such that the bob is hanging at least 2 cm above the base of the stand. Now mark a point A on the table just below the position of the bob at rest and draw a straight line BC of 10 cm having a point A at its center. The bob will oscillate over this line. Now get the stop clock and move the bob by hand over position B and leave. See, the bob oscillates over the line BC. Make sure bob is not spinning. Count the number of oscillations from the instance bob passes through its mean position where its velocity is maximum. We have to record the time taken for 20 oscillations. I will let the bob to oscillate for a couple of times and then after that I will take the reading. Now start the stopwatch at the instance the bob passes through the mean position A. As soon as it completes 20 oscillations, stop the clock. As you can see, the time taken for 20 oscillations is 23 seconds. Take at least another 2 measurements for the same length of pendulum. Repeat the same procedure for other 5 different lengths of pendulum. Observations. The Vernier constant Vc equals to 0.1 cm. It has no zero error. The mean diameter of bob is 1.87 cm. So the radius of bob r equals to 1.87 by 2 equals to 0.935 cm. The standard value of acceleration due to gravity g equals to 980 cm per second square. The least count of stop clock is 0.5 seconds and the stop clock has no zero error. The mean L by T square is 25.31. Calculation. We know T equals to 2 pi root over L by G. Therefore, the experimental value G1 equals to 4 pi square into L by T square, which is 4 into 3.14 square into 25.31, which is 998.19 centimeter per second square. So, the percentage of error equals to G1 minus G by G into 100%. Which is 998.19 minus 980 by 980 into 100 is equals to 1.86%. After that, we will plot L versus T square graph and determine the length of the second pendulum from the graph. To do so, in the x-axis I have plot L in centimeter and in the y-axis T square in second square. The scale factor is on x-axis 1 division equals to 1 cm and on y-axis 1 division equals to 0.1 second square. After plotting the graph, it comes out to be a straight line passing through the origin. Now, I consider a point P on the straight line. Then, I find its corresponding value L and T square. L is 25 cm and T square is 1 second square. Therefore, the acceleration due to gravity g equals to 4 into pi square into L by T square equals to 4 into 3.14 square into 25 by 1, which comes out to be 985.96 centimeter per second square. This is very close to the standard value 980 centimeter per second square. Now, I will find out the length of the second pendulum. To do so, I will take another point Q on the straight line where L is 100 cm and its corresponding T square is 4 second square. Or T equals to 2 second. This is a definition of second pendulum. Therefore, the length of second pendulum is 100 centimeter. Precautions. The thread should be very light and strong. The point of suspension should be reasonably rigid. The pendulum should be oscillate in the vertical plane without any spin motion. The floor of the laboratory should not have any vibration which may cause a deviation from the regular oscillation of the pendulum. The amplitude of the vibration should be very small, less than 15 degree. The length of the pendulum should be as large as possible in the given situation. Determination of time for 20 or more oscillations should be carefully taken and repeat for at least 3 times. There must not be a strong wind blowing during the experiment. So, these are the step-by-step procedure to perform a simple pendulum experiment. I hope you have enjoyed this video. If you like it, please share it with your friends. Subscribe our channel for more videos on experiments. Feel free to comment in the comment section. We will see you in the next video.